balloon. A hot air balloon is a lighter-than-air aircraft consisting of a bag, called an envelope, which contains heated air. Suspended beneath is a gondola or wicker basket, in some long-distance or high-altitude balloons, a capsule, which carries passengers and a source of heat, in most cases an open flame caused by burning liquid propane. The heated air inside the envelope makes it buoyant, since it has a lower density than the colder air outside the envelope. As with all aircraft, hot air balloons cannot fly beyond the atmosphere. The envelope does not have to be sealed at the bottom, since the air inside the envelope is at about the same pressure as the surrounding air. In modern sport balloons, the envelope is generally made from nylon fabric, and the inlet of the balloon, closest to the burner flame, is made from a fire-resistant material such as Nomex. Modern balloons have been made in many shapes, such as rocket ships and the shapes of various commercial products, though the traditional shape is used for most non-commercial and many commercial applications. The hot air balloon is the first successful human-carrying flight technology. The first untethered manned hot air balloon flight was performed by Jean-François Pilotre de Roger and François Laurent d'Arlandes on November 21, 1783, in Paris, France, in a balloon created by the Montgolfier brothers. The first hot air balloon flown in the Americas was launched from the Walnut Street Jail in Philadelphia on January 9, 1793, by the French aeronaut Jean-Pierre Blanchard. Hot air balloons that can be propelled through the air rather than simply drifting with the wind are known as thermal airships. A precursor of the hot air balloon was the sky lantern, simplified Chinese, traditional Chinese. Zhuge of the Shu Han Kingdom, during the Three Kingdoms era, 220–280 CE, used these airborne lanterns for military signaling. In the 18th century, the Portuguese Jesuit priest Bartolomeu de Gusmão envisioned an aerial apparatus called passarola, which was the predecessor of the hot air balloon. The purpose of passarola was to serve as air vessel in order to facilitate communication and as a strategical device. In 1709, John V of Portugal decided to fund Bartolomeu de Gusmão's project following a petition made by the Jesuit priest, and an unmanned demonstration was performed at Casada, India in presence of John V, the Queen Maria Anna of Austria, having as witnesses the Italian Cardinal Michelangelo Conti, two members of the Portuguese Royal Academy of History, one Portuguese diplomat and one chronicler. This event would bring some European attention to this event and this project. A later article dated on October 20, 1786, by the London Daily Universal Register would state that the inventor was able to raise himself by the use of his prototype. Also in 1709, the Portuguese Jesuit wrote Manifesto Sumario para os que ignoram poderes navegar pelo elemento do ar, short manifesto for those who are unaware that is possible to sail through the element air. He also left designs for a manned air vessel. The notable balloonist Julian Knott, in the 1970s, hypothesized that 2 millennia ago, the Nazca Line's geoglyphs creation could have been guided by Nazca leaders in a balloon, possibly the earliest hot air balloon flights in human history. In 1975, to support this theory, he designed and piloted the Nazca prehistoric balloon, claiming to have used only methods and materials available to the pre-Inca Peruvians 1,000 years ago. First manned flight. A model of the Montgolfier brothers balloon at the London Science Museum. The French brothers Joseph Michel and Jacques-Étienne Montgolfier developed a hot air balloon in Annonay, Auvergne, France, and demonstrated it publicly on September 19, 1783, making an unmanned flight lasting 10 minutes. After experimenting with unmanned balloons and flights with animals, the first balloon flight with humans aboard, a tethered flight, performed on or around October 15, 1783, by Jean-François Pilotre de Roger, who made at least one tethered flight from the yard of the Revillon workshop in the Faubourg Saint-Antoine. Later that same day, Pilotre de Roger became the second human to ascend into the air, reaching an altitude of 26 m, 85 feet, the length of the tether. The first free flight with human passengers was made a few weeks later, on November 21, 1783. King Louis XVI had originally decreed that condemned criminals would be the first pilots, but de Roger, along with Marquis François d'Arlandes, petitioned successfully for the honor. The first military use of a hot air balloon happened in 1794 during the Battle of Fleurus, when the French used the balloon L'Entreprenant for observation. Jean-Pierre Blanchard became the first person to fly a hot air balloon in various countries, including the United States, the Netherlands, and Germany. His most notable flight crossed the English Channel heading to the Dover Castle accompanied by Dr. John Jeffreys, which occurred on January 7, 1785. In 1808, Blanchard suffered a heart attack while ballooning above The Hague, fell from his balloon, and experienced fatal injuries. His wife Sophie Blanchard continued his profession, but also died a decade later on a balloon, due to a firework festival causing the hydrogen in the balloon to be set on fire. Modern balloons. A hot air balloon over the city of Helsinki in September 2009. Hot air balloons, Cappadocia Sunrise. A pair of hopper balloons. Bristol International Balloon Fiesta. Modern hot air balloons, with an onboard heat source, were developed by Ed Yost, beginning during the 1950s. His work resulted in his first successful flight on October 22, 1960. The first modern hot air balloon to be made in the United Kingdom, UK, was the Bristol Belle, built in 1967. Presently, hot air balloons are used primarily for recreation. Records. Hot air balloons are able to fly to extremely high altitudes. On November 26, 2005, Vijay Patsinghania set the world altitude record for highest hot air balloon flight, reaching 21,027 m, 68,986 feet. He took off from downtown Mumbai, India, and landed 240 kilometers, 150 mi, south in Punjab. The previous record of 19,811 m, 64,997 feet, had been set by Per Lindstrand on June 6, 1988, in Plano, Texas. On January 15, 1991, the Virgin Pacific Flyer balloon completed the longest flight in a hot air balloon, when Per Lindstrand, born in Sweden, but resident in the UK, and Richard Branson of the UK flew 7,671.91 kilometers, 4,767.10 mi, from Japan to northern Canada. With a volume of 74,000 cubic meters, 2.6 million cubic feet, the balloon envelope was the largest ever built for a hot aircraft. Designed to fly in the transoceanic jet streams, the Pacific Flyer recorded the fastest ground speed for a manned balloon at 394 km per hour, 245 mph. The longest duration record was set by Swiss psychiatrist Bertrand Piccard, Augusta Pickard's grandson, and Briton Brian Jones, flying in the Breitling Orbiter 3. It was the first non-stop trip around the world by balloon. The balloon left Chateau d'Oex, Switzerland, on March 1, 1999, and landed at 1:02 a.m. on March 21 in the Egyptian desert 500 kilometers, 300 mi, south of Cairo. The two men exceeded distance, endurance, and time records, traveling 19 days, 21 hours, and 55 minutes. Steve Fawcett, flying solo, exceeded the record for briefest time traveling around the world on July 3, 2002 on his sixth attempt, 20 in 320 h 33 minutes. Fedor Konyakov flew solo round the world on his first attempt in a hybrid hot air/helium balloon from 11 to July 23, 2016 for a round-the-world time of 268 h 20 minutes. Construction. A hot air balloon for manned flight uses a single-layered, fabric gas bag, lifting envelope, with an opening at the bottom called the mouth or throat. Attached to the envelope is a basket, or gondola, for carrying the passengers. Mounted above the basket and centered in the mouth is the burner, which injects a flame into the envelope, heating the air within. The heater or burner is fueled by propane, a liquefied gas stored in pressure vessels, similar to high-pressure forklift cylinders. Envelope. Modern hot air balloons are usually made of materials such as ripstop nylon or Dacron, a polyester. A hot air balloon is inflated partially with cold air from a gasoline-powered fan, before the propane burners are used for final inflation. During the manufacturing process, the material is cut into panels and sewn together, along with structural load tapes that carry the weight of the gondola or basket. The individual sections, which extend from the throat to the crown, top, of the envelope, are known as gores or gore sections. Envelopes can have as few as 4 gores or as many as 24 or more. Envelopes often have a crown ring at their very top. This is a hoop of smooth metal, usually aluminium, and approximately 30 centimeters, 1 foot, in diameter. Vertical load tapes from the envelope are attached to the crown ring. At the bottom of the envelope, the vertical load tapes are sewn into loops that are connected to cables, 1 cable per load tape. These cables, often referred to as flying wires, are connected to the basket by carabiners. Seams. The most common technique for sewing panels together is called the French fell, or double lap seam. The 2 pieces of fabric are folded over on each other at their common edge, possibly with a load tape as well, and sewn together with 2 rows of parallel stitching. Other methods include a flat lap seam, in which the 2 pieces of fabric are held together simply with 2 rows of parallel stitching, and a zigzag, where parallel zigzag stitching holds a double lap of fabric. Coatings. Hot air balloon safari in Masai Mara. The fabric, or at least part of it, the top 1/3, for example, may be coated with a sealer, such as silicone or polyurethane, to make it impermeable to air. It is often the degradation of this coating and the corresponding loss of impermeability that ends the effective life of an envelope, not weakening of the fabric itself. Heat, moisture, and mechanical wear and tear during setup and pack-up are the primary causes of degradation. Once an envelope becomes too porous to fly, it may be retired and discarded or perhaps used as a rag bag, cold inflated and opened for children to run through. Products for recoating the fabric are becoming available commercially. Sizes and capacity. A range of envelope sizes is available. The smallest, 1-person, basketless balloons, called hoppers or cloud hoppers, have as little as 600 cubic meters, 21,000 cu-foot, of envelope volume. For a perfect sphere the radius would be around 5 m, 16 feet. At the other end of the scale, balloons used by commercial sightseeing operations may be able to carry well over 24 people, with envelope volumes of up to 17,000 cubic meters, 600,000 cu-foot. The most used size is about 2,800 cubic meters, 99,000 cu-foot, allowing to carry 3 to 5 people. Vents. The parachute vent at the top of an envelope, as seen from below through the mouth. Souvenir hot air balloon. The top of the balloon usually has a vent of some sort, enabling the pilot to release hot air to slow an ascent, start a descent, or increase the rate of descent, usually for landing. Some hot air balloons have turning vents, which are side vents that, when opened, cause the balloon to rotate. Such vents are particularly useful for balloons with rectangular baskets, to facilitate aligning the wider side of the basket for landing. The most common type of top vent is a disc-shaped flap of fabric called a parachute vent, invented by Tracy Barnes. The fabric is connected around its edge to a set of vent lines that converge in the center. The arrangement of fabric and lines roughly resembles a parachute, thus the name. These vent lines are themselves connected to a control line that runs to the basket. A parachute vent is opened by pulling on the control line. Once the control line is released, the pressure of the remaining hot air pushes the vent fabric back into place. A parachute vent can be opened briefly while in flight to initiate a rapid descent. Slower descents are initiated by allowing the air in the balloon to cool naturally. The vent is pulled open completely to collapse the balloon after landing. An older, and presently less commonly used, style of top vent is called a Velcro style vent. This too is a disc of fabric at the top of the balloon. However, rather than having a set of vent lines that can repeatedly open and close the vent is secured by hook and loop fasteners, such as Velcro, and is only opened at the end of the flight. Balloons equipped with a Velcro-style vent typically have a second maneuvering vent built into the side, as opposed to the top, of the balloon. Another common type of top design is the smart vent, which, rather than lowering a fabric disc into the envelope as in the parachute type, gathers the fabric together in the center of the opening. This system can theoretically be used for in-flight maneuvering, but is more commonly used only as a rapid deflation device for use after landing, of particular value in high winds. Other designs, such as the pop-top and multi-vent systems, have also attempted to address the need for rapid deflation on landing, but the parachute top remains popular as an all-around maneuvering and deflation system. Shape. Besides special shapes, possibly for marketing purposes, there are several variations on the traditional inverted teardrop shape. The simplest, often used by home builders, is a hemisphere on top of a truncated cone. More sophisticated designs attempt to minimize the circumferential stress on the fabric, with different degrees of success depending on whether they take fabric weight and varying air density into account. This shape may be referred to as natural. 36. Finally, some specialized balloons are designed to minimize aerodynamic drag in the vertical direction, to improve flight performance in competitions. Basket. Hot air balloon basket in flight. A wicker basket capable of holding 16 passengers. Hot air balloon baskets are commonly made of woven wicker or rattan. These materials have proven to be sufficiently light, strong, and durable for balloon flight. Such baskets are usually rectangular or triangular in shape. They vary in size from just big enough for 2 people to large enough to carry 30. Larger baskets often have internal partitions for structural bracing and to compartmentalize the passengers. Small holes may be woven into the side of the basket to act as footholds for passengers climbing in or out. Baskets may also be made of aluminium, especially a collapsible aluminium frame with a fabric skin, to reduce weight or increase portability. These may be used by pilots without a ground crew or who are attempting to set altitude, duration, or distance records. Other specialty baskets include the fully enclosed gondolas used for around-the-world attempts and baskets that consist of little more than a seat for the pilot and perhaps 1 passenger. Burner. A burner directing a flame into the envelope. Burner. The burner unit gasifies liquid propane, mixes it with air, ignites the mixture, and directs the flame and exhaust into the mouth of the envelope. Burners vary in power output. Each will generally produce 2 to 3 MW of heat, 7 to 10 million BTUs per hour, with double, triple, or quadruple burner configurations installed where more power is needed. The pilot actuates a burner by opening a propane valve, known as a blast valve. The valve may be spring-loaded, so that it closes automatically, or it may stay open until closed by the pilot. The burner has a pilot light to ignite the propane and air mixture. The pilot light may be lit by the pilot with an external device, such as a flint striker or a lighter, or with a built-in piezoelectric spark. Where more than 1 burner is present, the pilot can use 1 or more at a time, depending on the desired heat output. Each burner has a metal coil of propane tubing the flame shoots through to preheat the incoming liquid propane. The burner unit may be suspended from the mouth of the envelope or supported rigidly over the basket. The burner unit may be mounted on a gimbal to enable the pilot to aim the flame and avoid overheating the envelope fabric. A burner may have a secondary propane valve that releases propane more slowly and thereby generates a different sound. This is called a whisper burner and is used for flight over livestock to lessen the chance of spooking them. It also generates a more yellow flame and is used for night glows because it lights up the inside of the envelope better than the primary valve. Fuel tanks. Propane fuel tanks are usually cylindrical pressure vessels made from aluminium, stainless steel, or titanium with a valve at one end to feed the burner and to refuel. They may have a fuel gauge and a pressure gauge. Common tank sizes are 38, 57, and 76 liters, 10, 15, and 20 US gallons. They may be intended for upright or horizontal use and may be mounted inside or outside the basket. Stainless steel fuel tanks, wrapped in red insulating covers, mounted vertically, and with fuel gauges, during refueling. The pressure necessary to force the fuel through the line to the burner may be supplied by the vapor pressure of the propane itself, if warm enough, or by the introduction of an inert gas such as nitrogen. Tanks may be preheated with electrical heat tapes to produce sufficient vapor pressure for cold weather flying. Warmed tanks are usually also wrapped in an insulating blanket to preserve heat during the setup and flight. Instrumentation. A balloon may be outfitted with a variety of instruments to aid the pilot. These commonly include an altimeter, a rate of climb, vertical speed, indicator known as a variometer, envelope, air, temperature, and ambient, air, temperature. A GPS receiver can be useful to indicate ground speed. Traditional aircraft airspeed indicators would be useless, and direction. Generating lift. Increasing the air temperature inside the envelope makes it less dense than the surrounding, ambient, air. The balloon floats because of the buoyant force exerted on it. This force is the same force that acts on objects when they are in water and is described by Archimedes' principle. The amount of lift, or buoyancy, provided by a hot air balloon depends primarily upon the difference between the temperature of the air inside the envelope and the temperature of the air outside the envelope. For most envelopes made of nylon fabric, the maximal internal temperature is limited to approximately 120 degrees C, 250 degrees F. The melting point of nylon is significantly greater than this maximal operating temperature, about 230 degrees C, 450 degrees F, but higher temperatures cause the strength of the nylon fabric to degrade more quickly over time. With a maximal operating temperature of 120 degrees C, 250 degrees F, balloon envelopes can generally be flown for between 400 and 500 hours before the fabric needs to be replaced. Many balloon pilots operate their envelopes at temperatures significantly less than the maximum to extend envelope fabric life. For typical atmospheric conditions, 20 degrees C or 68 degrees F, a hot air balloon heated to 99 degrees C, 210 degrees F, requires about 3.91 cubic meters of envelope volume to lift 1 kilogram, equivalently, 62.5 cu foot/lb. The precise amount of lift provided depends not only upon the internal temperature mentioned above, but the external temperature, altitude above sea level, and humidity of the air surrounding. On a warm day, a balloon cannot lift as much as on a cool day, because the temperature required for launch will exceed the maximum sustainable for nylon envelope fabric. Also, in the lower atmosphere, the lift provided by a hot air balloon decreases about 3% per 1,000 m, 1% per 1,000 feet, of altitude gained. Montgolfier. A Virgin hot air balloon flying over Cambridge. Standard hot air balloons are known as Montgolfier balloons and rely solely on the buoyancy of hot air provided by the burner and contained by the envelope. 50. This style of balloon was developed by the Montgolfier brothers and had its first public demonstration on June 4, 1783 with an unmanned flight lasting 10 minutes, followed later that year with manned flights. Hybrid. The 1785 Roger balloon, a type of hybrid balloon, named after its creator, Jean-François Pilatre de Roger, has a separate cell for a lighter-than-air gas, typically helium, as well as a cone below for hot air, as is used in a hot air balloon, to heat the helium at night. Hydrogen gas was used in the very early stages of development, but was quickly abandoned due to the danger of introducing an open flame near the gas. All modern Roger balloons now use helium as a lifting gas. Solar. A 4 meters high solar balloon floating over a meadow. Solar balloons are hot air balloons that use just solar energy captured by a dark envelope to heat the air inside. Steering. Hot air balloon can be steered to a limited degree by changing the altitude of the flight. Wind in the northern hemisphere tends to turn east due to Coriolis effect as the altitude increases. Safety equipment. This section does not cite any sources. Please help improve this section by adding citations to reliable sources. Unsourced material may be challenged and removed. August 2009, learn how and when to remove this template message. To help ensure the safety of pilot and passengers, a hot air balloon may carry several pieces of safety equipment. In the basket. To relight the burner if the pilot light goes out and the optional piezo ignition fails, the pilot should have ready access to a means of backup ignition, such as a flint spark lighter. Many systems, especially those that carry passengers, have completely duplicate fuel and burner systems, 2 fuel tanks, connected to 2 separate hoses, which feed 2 distinct burners. This enables a safe landing in the case of a blockage somewhere in one system or if a system must be disabled because of a fuel leak. A fire extinguisher suitable for extinguishing propane fires is useful. Most balloons carry a 1 or 2 kilograms of E-type fire extinguisher. A handling or drop line is mandatory safety equipment in many countries. This is a rope or webbing of 20-30 meters in length attached to the balloon basket with a quick release connection at one end. In very calm winds, the balloon pilot can throw the handling line from the balloon so that the ground crew